Hello guys, welcome back. This is Tronic Synergy. Now yesterday we did a DOL, a method of starting a motor. I hope you understood. It's a very simple way to start a motor. Just press forward, start to start the motor, then press stop to stop it. Yeah. So today we're going to check on a forward reverse. So the name just suggests what you're going to do. You just run the motor in forward and reverse, but it has some special circuitry. So once you press forward, motor runs in forward. You stop the motor, then press reverse to run it in reverse, then press stop. So as you can see, you have to press stop for it to run in opposite direction. If you run it in forward, you cannot run it in reverse directly, because there's a system we are calling interlock, and that's what we are going to discuss. Once you press a direction, you cannot change it directly. You have to press stop for you to change the direction. Now, here is the circuit of a forward reverse. It basically resembles that one for a DOL. If you understood DOL, now this becomes very simple. Yeah, we're just going to add some little bit of things, and that will be it. So as you can remember, we have MCB for fault protection, overload relay for checking the current of the motor. If it's too much, it's going to trip. If it's okay, it still remains to be NC. We have the NC stop push button. This stops the whole bottom part of the control circuit, so it's the main one. We have forward push button, we have reverse push button, and here down we have the interlock connection. Now the interlock works in this way. Once we press forward, this contactor coil for the forward is going to enter, and since it's powered, doesn't come directly as drawn here. It comes from auxiliary contact of contactor 2, which is the one for reverse. So you pass it to the auxiliary contact of contactor 2, then take it to that coil, and the same happens to here. It doesn't come directly from this push button. It goes to the auxiliary contact of contactor 1, the one for forward, then comes to this coil. Now the reason as to why we are doing this is because once you press it, if it's passing in that auxiliary contact of contactor 2 and coming to this coil, once this is on, it means that its auxiliary contact, which is this one for contactor 1, will become an NO. Once it becomes an NO, it means that however much you press this one, it won't power this coil, because there is an auxiliary contact which is open right here. So this becomes an open circuit, so you cannot power this coil. The same happens to here. Once you press reverse, you have to press stop in order for it to press reverse. So once you press reverse, the same happens. Since we power this, we have powered this coil, and it's the one for contactor 2, so this auxiliary will become open. Now once it becomes open, however much you try pressing the forward push button, it won't power this coil because there's an open circuit right here. So this is what we call interlock, and it protects the motor because the direct change of direction will not be very good for the coils inside, and also because it's an AC system. For you to change the direction of a motor, you change two phases. You will see that these maybe in the power circuit. This is a control circuit, there's a power circuit. Now because we change the direction, or we change two phases, pressing forward and pressing reverse at the same time will mean that you are shorting those phases, and that could bring a fault. Yes, so that's what I wanted to show you guys today, and the circuit here resembles that. So if I run it in forward, you cannot press reverse until you press stop for you to run reverse, then press stop. So the circuit is very simple. I'm still using the buck converter I was using yesterday to supply power. Today we are using an L298 motor driver, which is the one driving this motor. It's a H-bridge motor driver. We have a stop push button. Looks a little bit big, but it's just a simple NC push button. Here we have the overload, and the overload is still working, by the way. If let's say the motor draws too much current, the LED will turn on, and if it turns on, it means overload has tripped the whole circuit. If I try to press forward, nothing happens. I press stop. If I try to press reverse, nothing happens. I press stop. So now you cannot run the motor. You can't run the motor however much you want to try. But if it has not tripped, if the motor is just drawing the correct amount of current, you can run it forward, run it in reverse. Yes, So that's what I wanted to show you guys today. That's the forward reverse method of starting a motor. I hope you have understood. If you have any question, you can still ask me. I'm here. I'll be glad to answer you guys.